Hi everybody, welcome back to this course on Internet Technologies. I'm Vardhan and today we'll be studying about firewall configurations. Let's start with a very important term, the bastion host. If the network is your castle, think of this as your castle's gatekeeper. In firewall architecture, this is a specially structured system placed at the edge of the network. So, a bastion host is a specially designated system that stands as the primary line of defense in a network. It's assumed to be highly secure, not impenetrable, but certainly the most monitored and hardened computer in the setup. System administrators usually start by installing a minimal, secure version of an operating system on it, removing unnecessary services, disabling unused ports, and applying the latest patches and updates. It might also be equipped with multi-layer authentication mechanisms and is typically configured to act as a proxy, controlling access to other systems. Because it's directly exposed to untrusted networks like the internet, the bastion host must always stay under a watchful eye. In the previous lesson, we learned about different types of firewalls like packet filtering, application level gateways, and circuit level gateways. But now we'll focus on how those firewalls are configured in real world communication environments. There isn't a one size fits all solution. It depends of how many components you use and how you arrange them all. Broadly, there are three major architectures: single homed host, dual homed host, and the screened subnet. Each has its own strengths and security levels, and these configurations involve routers, bastion hosts, and private networks, all strategically placed to restrict or control access. In this diagram, you can see the basic setup of a single homed bastion host configuration. There's a packet filtering router that connects to both the internet and the internal network. The bastion host sits between the router and the internal network and is also connected to an information server. The router filters packets and forwards only specific types of traffic to the bastion host. This setup is relatively simple and cost effective, but has some security limitations, especially if the router is compromised. In a single homed host setup, the bastion host has only one network interface. It relies heavily on the packet filtering router to block or allow traffic. The router is configured to only allow packets destined for or originating from the bastion host. Once the traffic reaches the bastion, it handles authentication, proxy services, and application level filtering. While this setup does provide a layered defense, the main weakness is that if the router is ever compromised, an attacker might bypass security controls because the bastion host is directly reachable. So, although it offers basic protection, it's not ideal for high security environments. Now, in the dual homed host configuration, you can see that the bastion host has two network interfaces. One connects to the untrusted zone, the internet side, and the other to the internal private network. In between, we have the DMZ or demilitarized zone, a special area that contains publicly accessible servers like the information server. The packet filtering router ensures traffic goes only to the bastion host. The internal network is never directly exposed, even if the outer router is breached. In a dual home configuration, the bastion host plays a much stronger security role. With two NICs, it physically separates incoming and outgoing traffic. There's no direct path from the internet to the internal network. Even if someone manages to breach the packet filtering router, they'll hit a dead end at the bastion host. The network segment between the router and the bastion is called the DMZ, again the demilitarized zone, where public servers lie. This way, the internal network remains protected. This design offers much better control and is more secure than the single home setup. Now, this is the most secure configuration, the screened subnet. Here, two routers are used. One connects to the external network, the internet, and the other to the internal private network. The bastion host and information server sit in between them in the DMZ. The internal router is configured to accept traffic only from the bastion host. That means even if someone compromises the external router or public server, they still can't reach the private network directly. It's a full security sandwich with a layered defense. The screen subnet architecture is built for environments that need maximum security. It uses two routers, one connects to the internet and the other to the internal network. Between them lies the DMZ, where Bastion host and any public facing services are hosted. The inside router is extremely strict. It only allows traffic that comes from the Bastion host. So even if an intruder gains access to the public server or even the outside router, they still can't touch the internal network. And this layered design makes it very difficult for an attacker to move laterally inside the system. That's why it's considered the most secure among all firewall configurations. While all these configurations focus on stopping external threats, what if the intruder is already inside? Maybe a spiteful employee or a compromised internal machine? That's where intrusion detection systems or IDS come in. These systems monitor network traffic and look for anything unusual, like unauthorized access attempts or data being sent out. It's also wise to install desktop firewalls on individual systems, especially in large organizations. Another point to consider is the balance between security and accessibility, especially for intranets and extranets. You need flexible authentication, user roles, and encrypted communication, but all this should be done without making access too complicated for legitimate users. So that marks the end of this video, and in the next lesson, we'll be learning about security attacks. So thank you for joining in, and I'll see you next time.